Hi there, Rob, G7LAS. Been watching a YouTube channel for quite some time, TRX Bench. And the gentleman who presents that, Peter, is very, very good. His subject matter is pretty much the restoration of and repair of radio receivers and amateur radio transceivers, and the odd CB radio here and there. And as you may imagine, he has some quite high-end equipment for doing that kind of thing. But I watched with interest recently is episode 50, where somebody writes a letter to him and says, I'm really interested in realigning and restoring CB radios. So what is the most simple equipment I can get away with? Do we have to spend thousands and thousands of dollars in order to align these radios? And Peter's answer, of course, was no. It's not absolutely necessary, although the state-of-the-art stuff is obviously excellent. And one of the items he comes up with on his channel is this, and this is a relative AF voltmeter. So typically, if you feed a signal into a radio receiver and then plug something like this onto the speaker output or the headphone jack, something like that, this will rectify the signal, the audio signal that comes out, and display a relative reading on this milliammeter. If you want a proper description of this circuit, I recommend you go and watch his video number 50, where he goes into much deeper detail. But the idea is we can tune some of the filters within the radio. You've got your standard signal coming in, and as we alter the values of some of the inductors and that kind of thing within your radio, you can see this relative value on the ammeter increase and decrease. Very, very useful piece of equipment, quite simple. What I'm going to actually go through is how you take a circuit like this and turn it into the finished product. There are millions and millions of circuits like this all over the internet. A lot of them really useful like this. I'm going to go through the practical stages, the evolution of design, if you like, that changes it from this circuit into a finished product. Okay, so I've got 3 resistors here. Obviously these are not used in this specific circuit, but I'm going to use them to sort of point out various design methods we may use in order to implement this circuit. Now, simple circuit diagram like that, we may well just twist together some of the components and they could all be flying around inside a box. Just solder these twists and subsequently we make up something that looks like this, and it would probably work, but I don't find that particularly satisfactory. I don't like the fact that it's not particularly mechanically good, if you like. I like something a little bit more stable and solid. We could etch a printed circuit board for this. That seems a little bit overkill. So what I'm going to implement instead is this. A lot of newly qualified radio amateurs and electrical guys may not know what this is, but this is called tag board, and it was used extensively before printed circuit boards were used. Chances are, if you've got some Volve equipment at home, I've got a Volve based frequency generator. These kind of things were used quite a lot. And you can see this is called tag board, and each tag has 2 holes that you can solder things to. You can sort of see them slightly better there, so 1 hole there and 1 hole there. They're connected. And the principle is you take your component, you sort of put it through, off camera there, put it through one of the holes, twist it so it's mechanically sound. Not doing a very good job here, I'm working around the camera unfortunately. So it's mechanically sound to some degree, and then solder it on. So this is what I'm going to do. I'm going to use this. And I'll show the evolution of the design. Okay, So to begin with, we probably start off with something that looks very similar to this. You can kind of imagine that these points here are the tags on the tag board, and they're the ones subsequently at the top. And that would be a pretty easy way to design something. So let's sort of pretend that we've got these 4 tags wide. 1, 2, 3, 4. Let's sort of draw the components between it. So we need to connect our input to here. So they would probably be a couple of flying wires that go to something like banana sockets that you'd have on the front of the box. You'd have your 10 microfarad capacitor here. This line, we need to bridge that, so we need to put a piece of wire across there. Then you've got your germanium diode, which is used to rectify the incoming audio signal. So ultimately, between these two diodes, we're turning this into DC, so we can measure it on our ammeter. And what do we have here? Okay, so there's your 1 microfarad. Again, another wire bridge is needed. 47K. Old style of resistor identification there. Old habits die hard, I'm afraid. Can't teach an old dog new tricks. Also, we require an additional wire across here. And then we'd have probably a couple of flying wires connecting to the front panel of our box, where we would have our meter. This circuit diagram, let me make this completely clear, implemented on this board would work absolutely fine. We could connect the 10 microfarad across here, diode across here, the 47 across there, have the flying wires going to the ammeter, the input here, that wire that bridges across here. You can see the other germanium diode would go from here down to here, and that would work fine. But I think we can actually do a better design than that. And this is what I was talking about, the evolution of design. So we incrementally make this design better by pointing out, in effect, the faults and the things that we wish to correct from the previous step. So let's draw our 4 columns of tags again, or a tag board. 1, 2, 3, 4, excellent. And you have your input going into here. Just drawing a little AC diagram there. There we go, there's your 10 microfarad. Okay, so let's make this step getting rid of these wire bridges. These are superfluous requirements, we don't need these. We can take the germanium diode, instead of connecting it through here, we could connect it across here. We've done away now with this extra wire link. We can put our second germanium diode across here. And the negative side of this electrolytic, that's also connected to this same end of the input. So we could put it in like this, put the plus there. So what else do we have? Okay, so we've got a 47K resistor. Okay. We don't need to put that there, do we? We could put it down here. Let's take that out, put it onto this pin instead, and then we can have our ammeter here. Because one end of the ammeter goes to one of the inputs, the other end goes to this side of the 47K resistor. This pin is not being used, this tag. And also we've managed to reduce these 2 tags here. They're no longer required at all in this design. So we're actually getting somewhere. Let's try to implement use of this tag. And also, I don't like this capacitor. It's a long way, that, diagonally. Let's try and make it a little bit neater, if you like. Let's try and take this tag here and move it to here. So this would go on the electrolytic, will go here, the diode will go down there instead, this will go across here. It looks much neater. So let's give that a try. We only need 3 columns of tags now. 1, 2, 3. 1, 2, 3. So here again, we have our input. The 10 microfarad is here. As before, our first diode goes this way. Now we're going to move this down to here, so this diode effectively gets moved in its orientation. Make sure you keep the polarity the same. So you can see that they're almost like arrows and they carry on the flow the same direction, the same way these do. They're kind of following each other like a little train, both moving in the same direction. Your second electrolytic can go here. That's your plus, 1 microfarad. Okay. And now this side of the resistor can go here also. So this resistor is now like this. And the ammeter goes from that side of the resistor to here. And that's probably good enough. Must get a less wobbly camera, I do apologise. So the only diagonal component we have is this one. It's not travelling a particularly long distance. So we've got rid of this large span here that was previously on the electrolytic. We also got rid of any wire bridging, so there is no wire bridges now at all in this design. And that's pretty good. So looking at the tag board, we'll bring that along. We twist it around so we haven't got that resistor attached to it anymore. We can literally take this board, 1, 2, 3, cut it off here, apply the components to that in our new design, mount this in a box, and everything will be great. So in the next section, I'm going to go through putting components on here properly, making sure they are mechanically sound, soldering it all up, and we'll test. You must always test your circuits before you mount them in a box. The number of times I put things together end to end and they never work. We sort of unit test it. Every little bit that you could possibly test, you must before you move on to the next section. We'll do that, and then in the third part, the final section, we'll go through boxing it, putting the banana connectors on, and then showing it working in a real life environment. So catch you then.